So good evening everyone. Rishikesh buying this side. Today we will show you how to install Qiskit in your local machine. So I will play a pre-recorded video because it's not possible for me to show the installation right now because in multiple times you cannot install the Qiskit on the same machine. So I will guide you. So please let me know if you have any further query. Is it visible?
Yes.
Okay. So first of all, you just head on to Google and search for mini conda. Okay. Then you select Windows platform, that is Miniconda 3 Windows 64-bit. Please let me know if you have any further query regarding this or you are facing some issues. Then after downloading, you select the Miniconda 3 latest version from the downloads folder. Then you select I agree. Then here you please note down that you should install for just for me, okay? Not this all user, because later on it will create some conflicts. So don't do that. Then choose your required destination folder. Then again next. Then keep it as it is. Don't change anything here. Then again install. Then next. Then finish. Now you open Anaconda PowerShell prompt, okay? And here we have to create a new environment here. At present, by default, it will be on base environment. So you have to create a new one so as to prevent any kind of conflicts. So for that, type conda. Create double dash your name and the name of the required environment that you want to provide. Here I am naming it as Qiskit_env. Okay. Now wait some time. Then proceed with yes. Now you have to activate this environment that you have created, that Qiskit_env. And then press enter. Now you can see that the environment has shifted from this base environment to Qiskit_env that you have created earlier. Then you have to install some packages, okay? I'm proceeding. Like conda install pip. This is a Python package installer basically to install the packages. So first of all, you install the pip. It will take some time, considerable amount of time. So please wait. And after installing pip, you have to install some Python packages. So initially, we will install Qiskit, a software development kit that is used to interact with quantum computers with respect to some quantum circuits. So this will basically help you to generate the quantum circuits. That is the main task that we have to do. It will take some time, okay? I just skipped it. So after installing Qiskit, you just install Jupyter notebook. Now we have to install Matplotlib. Now we have to install PyLatency. Now our task is complete regarding creation of environment or all the installation of the packages. Now, if you have VS Code, then you can skip this, or else this is the installation of the VS Code. So as usual, just head on to Google and search for Visual Studio Code, and from here you download VS Code based on your operating system that you have. If you have Mac, then you can install it from here, Mac OS 10.5. And if you Windows, then you can select Windows 10 or 11. And if you have Windows 2, then you can select Debian Ubuntu or whatever you have. If the download has not been started, then you can directly select from direct download link. That is from here, okay? Sometimes it may not happen automatically. So again, you select VS Code, user setup, and you select the agreement, next. Then select your destination folder where you want to install, and keep it as it is, okay? You can check this one also. Open with code action to Windows Explorer, and this one. Open with code action to Windows Explorer directly. It will help you to open VS Code directly from the Windows Explorer. That's the use case. Now you install it. Now after installation, again we have to install some extension. So the first extension that you have to install is Python, okay? So from here, from this, you can say icon. You just as the extension icon, you just search for Python, okay? So from the first page, you can see here that Python will appear, and install this. One more thing you have to install is Jupyter, okay? Here. Then, after installation, you just head on to Explorer, and from there you just open a folder. You find out that an option is there, open folder. Okay, just create an open folder. After selecting, you just head on to your required location where you want to create that folder. Now here, you just create a folder for all your Qiskit codes basically. So I'm creating it as Qiskit. Now select this folder. Now trust all the author. Now under this folder, you have to create files. Okay. So for that, select on file, and from there you just select Jupyter Notebook. Okay. This will create a notebook for you where you will install, where you run or your Qiskit programs. Just name that file. So I'm giving it as just one. Save it. And to ensure that everything is all right, first of all, select your kernel. So from here, on the right hand side, you select the kernel and select Python environment. And from there, you can see that we have two environments. Okay, one is base and one is the one that is created. That is a Qiskit a_env. That's the one that I have created. Okay, select that one. Then in order to ensure that everything is all right, that is the setup process, you just type import Qiskit. And you just run it. And if you see that tick icon is just present, then it means that the installation process is all right. Okay. And in order to find out what's the version of the Qiskit, then you just type Qiskit dot _version _. See if you have this version or any later version, then it's all right. No issues. So, are you facing any problem or what? Just let me know.
We will later share the video on our Discord channel.
Yeah.
So you don't have any problem.
If you have any query regarding the installation process, you can ask right now. I'm giving you 5 minutes time. You just think about it and let me know. If you want any section to be repeated, please let me know, okay?
I think most of you use Linux also. So it's just for the Windows. And if you are doing something on Linux, then we can update this on our Discord channel. There are no complicated things at all. There are just simple instructions and commands you have to run on the terminal. So in the Linux part, today there is no actually time is short, so we can update the Linux part on our Discord channel. So be alert on our Discord channel and be active to get the resources about this.
Can you repeat the process of the VS Code, that how it is working Qiskit once again?
Okay, wait.
Just
First one
go
you
the
have
previous.
downloaded. First one you have downloaded VS Code, right?
Yeah, well, it's already downloaded. You just go there.
So after you have installed it.
Yeah.
Okay. Then open it.
Yes.
Then after opening, you just head on to your extension one. Okay. In the last one.
Yeah.
There you just search for Python.
What?
Python programming language. This one. Wait.
Python. Yes.
Then search for Jupyter. It's a notebook where you will write your Qiskit.
Yeah.
Install. It will take some time.
Yeah, it's already installed. Yeah.
Then you just go to this Explorer one. Top one, okay? Then you open a folder where you will save all your Qiskit code. Okay? Then select the required destination where you want to save. You can consider it down documents, okay? It will be better.
Okay.
So here you just create a folder and name it.
Yeah.
Name it as a Qiskit.
Okay.
Then you select this folder.
Yes.
Now after selecting it, you just trust all this author of this document. Okay. Then after that, you just create a file under this folder only.
Okay.
Okay. You just click on file, then new file. Then you select Jupyter notebook, not Python file. It should appear.
Yes, it's appear.
Yeah. Then after selecting this, you just select name it, that Jupyter notebook.
You need to save this one, okay?
You have to save this one, you just name it. Or it will get lost later on. After selecting it, press Ctrl S.
Okay.
Okay.
Yeah.
Appeared. Then name it.
Yes.
After naming it, you just select the kernel. Okay. From the rightmost side, you should have.
Select the kernel, yes.
After selecting kernel, select Python environment. It should show.
Okay, Python environment. Can you repeat this space once again, please? After selecting the kernel, then yes.
A menu should occur where you should
Yes.
see a Python environments or existing Jupyter server. Here I am showing it. You can see.
Yes, I select the kernel and then
Python environment. It's not showing?
No.
Then I think there is an issue with the creation of this environment or the installation of Miniconda. See, this is the simplest process that I have created, okay? Because on internet it's very complicated to install all such things. And I face all such things. That's why I'm telling you. It's a headache to install all such things. Have you installed Miniconda?
Yeah, I use the Miniconda. Okay, thank you. I'll check.
you just follow this part. Okay, I'm playing. Okay, I think
Yes,
this
yes,
is
yes.
important part.
Yeah, yeah.
So
Thank you.
initially, first of all, it will be on base environment. Okay, by default, it is showing already.
Yeah, yeah, yeah. Yes, already.
Base is showing, right? Hmm?
Yes, yes.
So by default, it should show. Then type conda create double dash, not underscore. Double dash name. Then name the, after naming it, just give the name of the environment. You can give it as Qiskit, env. Okay. Have you done this?
Yeah, yeah, yeah. Yeah, already.
After doing this, it will create an environment and it will ask for permission.
Mm-hmm.
And if you have already created with such name, it will also show a warning. So what it is showing right now? Is this showing proceed yes or no?
Just a second. Yes.
Proceed yes or no? Or what? Let's type.
Yes. Oh, they're showing the removing existing environment. So I think this is my environment already created.
I think then you have already created thing. What is the name of the environment?
Qiskit underscore Somir.
Underscore what?
Somir.
Shamir. So then write conda activate Qiskit underscore Shamir.
Yeah, yeah. It's already activated.
Activated. So the environment changed. Nah.
Yeah, environment is changed. Yes, from base to Qiskit Somir.
Then install pip. If it's already installed, again it will show warning. Conda install.
What install? Yeah, yeah, already. Okay.
Then you just type. It is already showing, right?
Yeah.
Pip install Qiskit. But it is showing.
Let's check something.
I'm repeating because it will help others also. Okay.
Yeah.
Because I know that many of you are really facing some problem while installing this. And in cloud also I can't show because that one is actually not available right now. Previously, earlier we have IBM experience. There is a cloud processing that's provided by IBM, but right now it's not present. I can't show. So you have to do it on your local machine only. What it is showing, it should show something. If anybody else is also facing some problem, so please let me know. Okay. Somebody, you let me know. Okay, when it is done. Have you all completed so that we can proceed in the next session?
Okay, if you have any problem, then you can tag organizer in Discord. In the we can better interact in the Discord voice channel. They will show better, I think. If you have doubt, then you can ask.
Samir, have you installed?
Guys, please interact. Then we can continue our session.
So if you have any further doubts, then you can contact in our Discord channel. Okay. Now Arunava Jodder will show you some sample codes just to make familiar with Qiskits. Okay. So I'm passing down to Arunava Jodder. Thank you.
So good evening, everyone. Is my screen visible? So let's start with a question. How many of you heard about the terms of quantum computing and wondered what exactly makes it so powerful? Well, today we are going to uncover some of the magic behind it through quantum gates, the building blocks of quantum circuits. Imagine if a computer could exist in a multiple states at once. This is what the idea of superposition comes in. And what if we could take two particles, put them a miles apart, a miles, even a light years apart, and still, still them instantly influence each other? That's entanglement, and it's mind blowing. So, in this session, we will start by discussing individual quantum gates such as Hadamard gate, the Pauli XYZ gate, and the phase shift gates like T and S. These gates help us to control quantum states and perform rotation on the qubit states vector. Then we will move on multi-qubit operations such as the C0, swap and Toffoli gate. You can say that in CC0 gate, which are crucial for entangling qubits and enabling quantum algorithms. We will explore this phenomena using Qiskit, starting with the key quantum gates like Hadamard gate, which creates superposition, and the C0 gate, which helps entangle qubits. But I won't just show you how this gate works and just raw code. I want you to really feel the power behind these concepts. So I have ready some animations about this. So I am showing you like this. You can see Hadamard gate, how it works. Because I want you have to understand the concepts behind these gates. So we will even dive into something really exciting further. So let's jump right in. Start with the gates that makes all this possible. So we are starting with some Hadamard gate. So the Hadamard gate is one of the most fundamental quantum gates. It creates superposition, transforming a qubit into an equal mixture of the gate 0 and gate 1. Like I can say, I can write again for the gate. You won't understand this. This is gate 0 and this we can say the gate 1. When applied to a qubit in the zero state, it results a state that is an equal superposition of gate 0 and gate 1. So I am showing a Hadamard gate to you. First, you have to see. So we are importing some files from that library, Qiskit, the quantum circuit, and we have to visualize the gates actually. So this Qiskit visualization is important. So starting a fundamental gate like Hadamard gate. So I am naming the just the first, as it's a first gate, so I am naming it just gate 1. So now this is the important part, Q.H. This denotes the Hadamard gate. So I am denoting 0, the gate 0 state first. Now, there are two functions. Like we can print the gate or we draw the gate by through MPL. First, I'm printing the gate. Is it visible to all? You can see this is our Hadamard gate. Let's zoom in. Did you see this Hadamard gate? So this seems some boring things. Let's move it, draw with MPL. It takes time. Now you can see this is an Hadamard gate. So let's talk about some Hadamard gate. The Hadamard gate can be seen as the rotation of pi. You have to face problems. So I'm just visualize these things like this. Yeah. So the Hadamard gate can be seen as a rotation of pi about the x z axis of the block sphere. I think in the previous session you have an idea what is a block sphere actually. So this is a block sphere and see the Hadamard gate's position. It's a primitive form, so it's already an elementary gate, and so there is no further breakdown of this Hadamard gate. Now moving on the Pauli. So first of all, we are going to Pauli X gate. So as same process. So I am copying these things. Don't make it repetitive. So Pauli gate has the three gates. It's X gate and Pauli Y gate and Pauli Z gate. I'm showing all the visualizations about this. So just wait and watch. First, how to apply on Pauli gate in the Qiskits. Well, let Q see what happened. Yes, as I'm starting from X gate, so X and apply a 0 state. Now I'm printing it. Actually, printing get the faster results, but when you go through the QC draw, it seems boring. I'm going to QC draw. You can see this is Pauli X gate. Just wait for the visualization. Look at that. This is what in the block sphere. You can see the rotations of this gate. You can see the rotation of Y. So let's make it. Oh, no. Actually, I'm a bit nervous. It's my first presentation. So don't mind. So let's see QC draw like that. You know. And here it is. But now the Pauli Y gate applies a 180-degree rotation around the Y axis. So we are going to that. Yes. It can be decomposed in a sequence of rotations about the X and Y Z gates. So let's further break down. Actually, it's not a basic gate, so we can break down it like this. So let's break down. QC and quantum circuit and the QC draw. This is needed much more. I don't delete any code so that you can understand each and everything. And I will share this in our Discord channel. So keep an eye on that. So let's break down the Pauli Y. I will I will share the breakdown in the Google chat also. So first see this how this works. You see it also. Well, let's see. This is Z gate actually. So I have like a yeah. You can see this in qc.x, qc.y, qc.z like this. So I'm not going to show you qc.x. That how the y gate comes in. This is the thing. This is the breakdown of these things. qc.y, not y. This is z and 0. Now see what happens. Here we go. This is actually this. This is the breakdown of these things. This is the breakdown of this thing. Pauli Y gate. So Z gate. Well, let's make the Z gate here so that we have to keep the sequence. Again, QC draw and QC. Well, let's see. First, make that QC draw first. Then we have to see these things. Got it. Let's see. QC dot Z. And these things here. That is Z gate, that is Y gate, and on the combination of X and Z makes that Y gate. Now we are going to show you some phase gates. Well, 1 minute. Did you understand everything?
If you have any query, you can ask. Okay.
Well, if you have a problem, then you can go for our Discord channel. Actually,
No, it's work fine. It's work fine.
Okay. Till now, it's good.
Yeah.
Okay.
Samir, have you completed the installation?
Yeah. It's work for me now.
Yeah.
Samir, if you have any problem, then you can find our Discord channel. We will help you
No.
in that.
I have no problem still. We just
Thank you.
think it work fine. Yeah.
So now, I'm going to now form some phase gates, T and S gates. So let's do some phase gates. So the T gate is a pi by 4 phase shift gate, and it adds a phase of pi by 4 to get one state. So let's see how the phase gate works. It's just about the states actually. I've shown these things. Something. Yeah, this is Z measurement. So well, if I found the phase gates, then I've shared the visualization in our Discord channel. So let's see phase gates. QC. I'm just giving you a basic idea about how to code on these things alongside with the concepts. So I think it's not be problematic, and I'm doing slowly. for the better understanding. So let's see. This is fine. So as usual, QC dot S makes it 0, and here we go. This is the S gate. The S gate is a pi by 2 phase shift gate, and it adds a phase of pi by 2 to the gate 1 state. So this is an S gate. So just 1 minute. Remember one thing. I'm here commenting it. S gate is pi by 4. Listen, I'm writing this. Sorry. Very sorry. S gate is pi by 2. And when we are doing T gate, then I am seeing the things like as usual. Quantum circuit, QC.drop. Sim, QSIM, you can write QC.T 0. And here we go. This is T gate. And now the T gate is pi by 2. Actually, what is pi by 2? That is pi by 2, sorry. I'm sorry. Pardon me. The T gate is a pi by 4 phase shift gate. So I'm like, this is so confusing. So even I'm confusing. So I can understand you. So I'm writing these things here. So pi by 4 and this is pi by 2. Is pi by 2 and T pi by 4. Well done. S gets completed. Now here we are completed all the single qubit gate. There are many more, so I'm not showing all of this. Now what we are going to do? Now we are going to see first some swap gates. Let's go for it. Swap gate. Yo, where we are. So now it's 2 qubit gate. So let QC so as 2 qubit gate is 2. So let's talk about some swap gates concepts. The swap gate swap the states of 2 qubits. If one qubit is in state 0, and the other is in state 1, the states are basically exchange. Like just a minute. तुम लोगों को ये सब टेम्पलेट पहले लिख देता, बाद में यही दिक्कत करता है. Got it? So let's see. Suppose this is 0. This is gate 0, and this is gate 1. So what swap gate does? Swap gate just exchange the state. If this is input, the output must be this. Clear? So now, how to write it? Like I'm commenting it. If this is so, this is not basically the standard notation. I'm just writing this to understand you better. So these things in the commented section help you to understand the concepts actually. So this is OP. This is IP. Good. Now swap gate. We are writing these things. Swap. What the swap? You can see swap. Now 0, 1. So as per we have written here. What happened? Well, these things I have made some mistake. Pardon me. This is here. This is the notation of the swap gate. Further, I am seeing these things like print QC. This is the thing that is cross on the both sides. Just it's denotes just some exchange. So better to understand this. This will be better. Now coming on. Well, I'm going to the breakdown of the swap gate. So let's go for the breakdown of the swap gate. How this swap gate comes. So to understand this, you have to understand the C0 gate. So going for the C0 gates, I'm going. So first I'm telling about the C0 gate, then I'm going to the breakdown of the swap gate. And even C0 gate has also a breakdown. So I will also see these things. So first going for the C0 gate. The C0 gate actually is a 2-qubit gate that flips the state of the target qubit if the control qubit is one state. Like if there are 2 qubits, like one is control and another is target. Understand? So just a minute, I'm commenting these things for understanding these things. One is controlling and another is target. Whom is controlled? So control means I'm saying if the control state is 0, what? Well, if the control state is 0, I think visible. Make it bigger. No, that is okay. If control state is 0, then target state will not change. Just see. It remains same. If it's 0, then it's 0. If it's 1, then it remains on its state. And somehow the control state becomes 1. Now it can change the target qubit to 0. If it's 0 in the target qubit, suppose the target qubit is 0 and the control qubit is 1, then it can change into the qubit into 1. This is the phenomena of this gate. So code it down, let's say. Actually, I'm not deleting any code. So you have to understand the sequence. The sequence is very important. Just I have to copy these things for the better. Oh well, this C not gate we can denote this C and X. That is C not gate, and running these things we can look which is control qubit and which is target qubit. This is the control qubit, the dotted, and the plus sign you can see that is target qubit. I think you have gained some knowledge about the introductory session. This session will some application, not, and the introductory session is just theoretical. Sir is the best way possible. You have to understand this thing. Sir tried it. Yes, sir is there. Okay. So this is control qubit and target qubit, and this is the C not gate. Now I am talking about the breakdown of the swap gate. So let's jump into it. Swap gate is just a mixture of C not gate. And how this configuration of the C not gate makes a swap gate? We need 3 C not gates to get a swap gate. So let's talk more about code. Well, why I'm writing these things at all? Just to control C and control V, delete these things. QC.cx, like 0, 1. Again, actually 3 not gate I am trying to write. 1, 0. Again 0, 1. And we are done. Here it is. You can see this is actually a swap gate. This gate is turned into this. This is the swap gate, and by denoting it by C not gate, we can get this. So you can say further C not gate can be further divided. So let's go for this. Again, I am copying this share. Just a moment. So for the C not gate, we can decompose it by some Hadamard gate and Pauli X gate. So make it clear. Just go for the code qc.h. qc.cx 0 and 1 qc.h. Make it clear. 1. These things are header mud gate and a CNOT gate. Now go for this. And here we go. This is the thing. So now we can move further to Toffoli gate. Just a minute, I have to check the schedule. Toffoli gate, and hereafter we can do multi-controlled CNOT gate, and that's all. I think I just have no time actually. So superposition state I'm showing you. I've already coded actually. So just I have to show the CC not gate and multi-controlled C not gate. These two things. Then I'm just going to show the entanglement and to Bell states and further anything. So just see. So we are done now. CC not. CC not. You can say it Toffoli gate. The CC not gate or Toffoli gate is a 3-qubit gate that flips the target qubit only when both control qubits are the gate 1 state. You can understand these things when there are 2 control qubits. Going to that thing. Here in the CNOT gate we are seeing just one control qubit, and here we have 2. Like I am naming it control 1 and another control 2. So when both of them are 1, just a minute. When both of them are 1, then only the target qubit changed. Here I am changing the target qubit 0. If just one qubit is 1, then it has no effect. Actually, it is essential for reverse computing. Just show. Let me show you just one thing. Not actually easy. This is easy peasy. Like what happened? Oh, I have copied this. Copy paste. What it is? Like these things. So we have to write this Toffoli gate. qc.ccx 0, 1, 2. Let's see what happens. It took time, and here I'm getting some error. What happened? Well, let's do again. Indexes. qc.ccx. Well, let me show you this one. This is the Toffoli gate. Now, why I am getting the error? It's extended CNOT gate, but why I am getting the error? I am getting the error just because of this thing. This is important, guys. make it clear. This is important. This is not a 2-qubit gate. 1, 2, and 3. 3 qubits involved in the result, not just 1 qubit. So write it again. That's why we can find the list is index out of range. So now do these things and see. We are done. Now I'm going to show you multi-qubit CNOT gate, and not last, but I am last coded these things. So MCX, multi-qubit gate. The multi-controlled CNOT gate can be expressed using a combination of Toffoli gates or a series of CNOT gates and Hadamard gates. So actually the number depends on control qubits. So I am just coded these things. It actually flips the target qubit only when all control qubits are in the gate 1 state. Like it's not about control 1 and control 2. It's a multi-control.
Hi, Arunava.
Actually, I have some. Yes.
Yeah, can you go to the code?
Which code?
That your code, you are working on that code. Go up. What is this function, quantum circuit?
Actually, quantum circuit, we have to go to the further. Yes, quantum circuit is just a.
What this library API? Why you are calling this API? What is basically this API working?
Actually, your sound is not coming. So, please.
Yeah, am I audible?
Yes.
You are calling that library like quantum circuit.
Okay.
Go to the code.
Yes.
Why you are calling this library and what is the function of this library?
Well, quantum circuit, it's just a class that comes from the Qiskit. Which you have downloaded before that. That's all. It's quantum.
What is that mean? Means
to.
you call the library, right? You call the
Yes,
library.
it's a library.
It's a library. Means Qiskit is the main class object. Qiskit is the main class object, and what this quantum circuit basically working? Why you are calling this API?
Quantum circuit is the library which it all actually stores the information about the quantum circuit, about the quantum circuit operation. Like you can say
it's a basically visualization library kind of.
These things are already coded. Actually, I am showing you.
Means this is a visualization library, right?
Yes, kind of.
Okay,
just a minute. Here is the.
You are using third-party libraries, basically. Okay, I got
not third-party. It actually from the Qiskits, like that.
These are the third-party libraries. Basically, that it is a IBM developed this, right? So the patent is also of the IBM.
It's an like PyPy you have done. The many
pandas,
other
like a pandas, like a NumPy, like a matplotlib.
Yes. Actually, you have you done any projects on BioPython or anything else? Just a minute. Have you done some BioPython library and PyPy?
I am a data scientist. I am a data scientist.
Yes. That's
so
all.
that's why I'm asking this, because I'm this library. So that's all. Thank you. Because I'm not understood why this library we are using and what is the working methodology. That's why.
Basically, before defining the number of qubits, you need the circuit to be defined. Okay, it's just the lines, you can say lines of circuits. You are just defining the number of qubits. So how would you know that how much number of qubits that you require in order to develop that circuit? So here we are defining that for applying one gate, we are using only one circuit that is possessing only one qubit.
So Qiskit having only this function.
Yeah. For creating the circuit, it is predefined.
Are you sure? Are you sure that object having only one function? There is no
another. For creating circuits, till now we know that you have to use this function only, quantum circuits.
Okay. Well, I worked on that, so there will be some different method. Yeah, you can carry. Thanks, bro. Thanks.
Hope you understand these things. Okay, further you have more queries, I know. Then you can go for our Discord channel. Again, I'm telling this.
Arunava, sorry to interrupt. Can you hear me, Arunava?
Hello, sir. Yes, sir.
Yeah, okay. I think you can just start from the beginning, like this. What is quantum circuit? Just very quick brush up. I think rest of the things, advanced things, we can discuss later. Also, we have Discord platform.
Okay.
So,
Okay.
what is quantum circuit
Sir,
and what is quantum
I have
register
just-
and physical register? Yeah, this thing and the packages that you can just quickly mention.
Okay.
Yeah, that will be better
Oh,
for
I have
beginner.
I have just one gate is
Fine. Okay.
just
Carry on.
one gate is remaining. This is multi-control CNOT gate. I have shown this thing. Then after I am going to see all the packages and libraries again.
Yeah, sure.
Like this. I have already listed these things. Qiskit's library. So I'm showing these things at all. Just a minute. Just wait for hold tight, guys. What happened? Well, so for the library, I'm going to where we have the multi-control CNOT gate. So we are doing some here. We have to import some file. So I'm writing these things from. I'm importing mcx get because what happened? Because you can't define these things at all. Now, so I'm going for quantum circuit 4. You see, quantum circuit 4. And here we go. QC draw. Going somewhere.
QC dot draw.
Sir, can you see the error, please?
Yeah, it's QC dot draw, not comma.
QC.
At the last line. At the last line. Go at the last line.
Oh.
Good.
Yes. So I have ready here all the things. for better understanding. So this is the multi-controlled CNOT gate, and here we can see the three control qubit, and all have the same values. Then only these things will change. Now I'm not finishing here. I've shown some entanglement and like this. Like you can see this, and this sign is important because it here I am going to show something about Bell states or some teleportation, and on these things this is important because only these things turns a quantum bit into classical bits. This dial type sign you have to see, and I've done many of these things like Bell states and just one of them like teleportation. It's a kind of teleportation gate. You have to further know about these things, and here you are. I'm completing my session right now, so if you have further queries then you can ask. I know this library and some sort of things may be confusing a bit because you. So if you have, I have shown something about you. Let's see, entire screen. Got it shared. Okay, let's see. Here it's the official documentation of IBM. If you have any doubts about this, anything, any type of doubt about the technicalities, or about the libraries and some APIs and many more, you can go for these things. Read the documentation, and here and mostly you can find all of your doubts about these things, and you can explore about the how Qiskit is not about the quantum circuit. It's some about creating phases and many more. You can go for this library. I'm paste the link about this documentation here, and it's actually extension like you have downloaded already, so you know all of these things about these things. This is the latest version, and there are many versions about it. There are in previous we have some use AER or many more things, which till now this is not here today, and here it is. So if you have any further query, then you can go for these things. Just IBM documentation, create an IBM ID, and then you can explore about. Actually, I am not suggesting you to use their local machine because this makes so clumsy actually, and some these visualizations are not working properly. So better to follow the video of this installation and make it here. So I'm ending my session right now. If you have any doubt, you can ask us.
Actually,
Well,
I have a question. Like in this quantum computation, the teleportation is done, right? So, how much distance is required? Like you told previously, ki it's like one or like for example, 1 kilometer, 2 kilometer, that amount of distance, like light years. If the particle is entangled, right? So the question is like if the particle is entangled like many light years. So imagine a scenario like if a particle going just goes to the spin up or spin down position, then we can know about the quantum states of this entangled particle, right? So if the information we already got faster than speed of light, right? So question is that something is breaking like physical laws, fundamental physical laws. The speed of light is not constant at all.
yes. I'm requesting Shumanto sir to make these things clear about this queries. And Ashwin Raj is raised and hand. Sir, are you there? Hello, sir. Actually, I'm not. I don't want to tell about these things because.
Arunava?
Yes, sir.
Actually, nothing to worry. Actually, this is a very good question, and we'll also answer it tomorrow. Actually, next day itself, we have the session on entanglement and teleportation. After Devajyoti, we'll start first about the notebook. Then we'll be discussing first entanglement and then teleportation. And also, there's a good question. You can write also this thing in Discord. But however, we'll be discussing the questions regarding this. This is a beautiful question.
Sir, basically the thing is like if the particle can talk like a vast amount of distances, then if the speed of light
Actually,
is constant,
this quantum entanglement is, you can see, if we see a quantum teleportation in case of, but as you are asking, because this is not clear to all of you, but still, I think in case of teleportation, one object, suppose I am sending one object to whatever distance may be at any infinite distance, forgetting about speed of light, I am coming to this point. Right? So one object is being destroyed from my side, and where I am sending it, that object will be appearing there because of no cloning theorem, right? I think you have heard about this, or no cloning theorem is you cannot make a copy of this. This is the property of quantum mechanics. And that advantage we exploit also. Yeah. And there are how many nodes or hops are also there. There's a point of research there in between two nodes or two stations, station A and station B, during quantum teleportation. Yes. Yes, someone.
that
Yes.
kind of real that you can.
Yeah, that I will be discussing as far as. Okay, Oswin is asking. Just a minute, just a few seconds. Give me. Then I am coming. Just a few seconds. Yeah, as Borun was asking that. Yeah, regarding teleportation. Yes, the teleportation here. Yes, was.
Excuse me, sir.
Yes, like you can hear.
Yes, sir. Sir, we are from first year and we are facing very difficulty to understand this type of things.
Which thing can you specify? Or if you cannot specify entirely here, there are channels for you. You can write thoroughly where you have clear idea. Where suppose we have got a session, right? have got a session. I will be sharing the video recording. This is being uploaded. So that is actually during the work hours I cannot do this. So the sessions are at night, or I will try to upload in YouTube at night, at night, or next day evening. So that time I need, and I will be sharing the recording. Suppose previous session there are some little bit maths like column vector like this. If you have any issue there, if you have any issue like NOT gate, Adamant gate, so please mention. And that is actually genuine thing, because you are from first year, also second year. I think they can face also some issues. But some students from M.Tech or PhD or B.Tech final year, they I think they can understand. They can like Prokurur is asking here. So he is actually asking
Sir,
about one of the question here.
Sir, actually,
So anything, any doubt. So it is basic, advanced. Do not be shy. Okay, please write it, or you can write it. That is here also in this session. Yes, Varun. I think Ashwin is clear what I am saying.
Sir, actually,
Yes.
in the form, right? So in the form, in the assignment, right? So there
Yes.
is like M.Tech first year, second year. We are actually in M.Tech third year student.
Oh, okay,
So-
okay. The MTech third year is also there, right? So I will add it. Just after the session, I will edit this. You can upload. Yeah. Thank you for noting it. Okay, we'll discuss this also. So I think Arunava, if you are done, then end this with your remark, ending remark.
Sir, I have done from my side, and I just want to tell you, if you have any doubt, then go for our Discord channel, and then on again we are trying to get a solution for you. And furthermore, if you have any problem about installation, you can also write these things about our channel. I know there are multiple systems, there are multiple OS, and the installation process is a bit clumsy. So if you face any problem, then you can go for our Discord channel. I'm ending here. Thank you.